Hello and welcome to a brief overview of the 2021 Blender Render Farm Capstone project. My name is Justin Slater and my teammates are Jacob Smith, Elizabeth Hurto, Tyler Haggart, and Bo Stensgaard. Our sponsor for this project is Guy Hokinson. For this project, we were tasked with creating a render farm for Blender animations to be used by NDSU students and faculty. A previous implementation of this project exists already, but is outdated, and as a result, we started from scratch with our implementation. With our desktop application, a user can upload a blend file, modify certain parameters pertaining to said file, and render their work remotely on the Linux machines in QBB 244. In order to take advantage of the render farm, a user must have a valid NDSU email address. Using their email, they can create an account and then verify the account with a code sent to their email. To submit a job, simply drag and drop a blend file into the application and fill out the submission form, which allows the user to specify a job name, Blender version, step frame value, start and end frame value, image format, and whether they would like their frames to be stitched into an MP4. After submitting a job, a user can view the status of their renders in the job status page. From here, a user can pause and resume a given job, delete a job, and once the job is finished, download their rendered frames and video.
Given that we're working with the lab machines, we needed a way to handle communication between each machine. This was done through sockets in both C and Python. The structure was the broker listening for connections from each respective node, accepting said connections, and then sending each message. This was all handled in a multi-threaded structure so that messages between each connection could be sent concurrently. There was some issues, however, largely with messages being cut off or attaching weird null characters. There was also an issue with machines not ending sockets correctly when they terminated, so when you tried running the program again, you would get a communication error. The structure was modified a bit, and the code here demonstrates a bit what was changed and what it does. Essentially what the C code does is it creates a network socket and then binds itself to the given IP address, in which it then listens for connections, accepts a connection, and then receives a message from the Python file. Finally, it writes a message to a text file. The Python file operates in a very similar way, but one special thing to note is that it actually runs the C file from before, and then tries to make a connection with the now run C file. The Python sends a given command, and then receives a message back.
The way we render blend files is rather simple code-wise. When a job is uploaded, the frames for that job are broken down into partitions of a set length. Then, any available machines are given a set of parameters that are used to create a render command. The lab machine checks to see if a given blend file is already in its local memory, and if not, copies it over from shared memory. Next, it creates a render command and runs it via the command line. Here is an example render command. First, we specify the version of Blender to use, then we tell the machine to render in the background. Then, we give it an output path for storing rendered frames, then an image format for those frames, the render engine to be used, start, end, and jump frame values, and finally, we tell it to take advantage of both the GPU and CPU when rendering. When I run this command, you can see the machine begins rendering the blend file.
The first suggestion for future teams will be to implement Eevee, since many may not care for photorealistic rendering provided by Cycles, which is highly time-consuming. Future teams should also consider support for Blender add-ons and possibly a way for them to be dynamically installed based on each submitted job. We also lacked proper unit testing and did not implement live updates for each Blender job being processed. And finally, future teams should look into implementing admin support for the desktop app.